Hello बच्चों, let's read the question. The question says here, a thin lens has focal length f1 and its aperture has diameter d. It forms an image of intensity I. Now the central part of the aperture up to diameter d by 2 is blocked by an opaque paper. So the focal length and image intensity will change to what? Let's find out. So we have the focal length of the lens as f, as f is focal length. Okay, its aperture diameter is d, and the intensity of the image formed is I. Intensity. Okay, so we have to find the area of the aperture when the central part of the aperture up to diameter d by 2 is curved by an opaque paper. So let A1 denote the initial area of the aperture and A2 initial area of the aperture. A2 is the area once the aperture is covered by opaque paper. Covered by opaque paper. Since the aperture is spherical, we have A1 is equals to pi into d by 2 whole square is equals to pi d square divided by 4, where d by 2 is the radius of the aperture. Radius of aperture. Okay, the central part of the aperture up to diameter d by 2 is now covered by an opaque paper. Then the area will be A2 is equals to pi d square by 4 minus pi into d by 2 whole square divided by 4. On simplifying, we get A2 equals to pi d square by 4 minus pi d square by 16. So, or we can also write A2 is pi d square by 4 into 1 minus 1 by 4. So finally we have A2 is equals to 3 by 4 into pi d square by 4. Okay, so as intensity is proportional to the area, we have to find the new intensity. So what we have, A1 is equals to pi d square by 4 and A2 is 3 by 4 pi d square by 4. So express A2 in terms of A1. So now we have A2 is equals to 3 by 4 A1. Okay, so the intensity of the image is directly proportional to the area of the aperture of the lens. Let I1 be the initial intensity. Initial intensity. I2 be the intensity when the central part of the aperture was covered by an opaque paper. Central part covered by opaque paper. Okay, so that is I1 by I2 is equals to A1 by A2. So substituting A1 and A2 in the above relation and cancelling out the similar terms, we have I1 by I2 is equals to 4 by 3. So here I2 is equals to 3 by 4 I1. So it will be 3 by 4 I. Okay. Therefore, the new intensity is 3 by 4 I. The intensity decreased as some light rays were blocked by the opaque paper. So we'll discuss what happened to the focal length. The focal remains the same when the central part of the aperture up to diameter d by 2 was blocked by an opaque paper, because the entire image will be formed by the light rays that were not blocked by the opaque paper. Okay, therefore the focal length is f. So here option D is the correct answer. Thank you.